Hi everyone, welcome to the part 2 of Benzyne intermediate. I hope you have referred part 1. If not, please do so. I'll just give a quick revision or recap of part 1, which is the important part here. That step 1, we have created benzyne with the help of NH2 minus going to attack on hydrogen, and followed by that Cl comes out, formation of benzyne take place. Remember this thing? And then later this benzyne is being attacked at two different positions to give you two different answers. Please refer the previous video for further details. Now in this video, we will talk about what if we get a situation when you have both the positions blocked. For example, we have CH3 here and CH3 here, and you want to do the reaction with NH2 minus and try to do some substitution with K plus NH2 minus or Na plus NH2 minus. So for this kind of cases, since both side substitutions are there, okay, both the positions are substituted or occupied, we will say that this kind of thing cannot give us any product. Reason is very clear, because the step 1 of benzyne mechanism, if you remember, was extraction of hydrogen. So if H is available here, once CH3 is there, I can go and take this H from this side, right? This can be taken. But if H is not there, if both sides are CH3s, we cannot grab H. So the reason for this is, since extraction of H plus is not possible. I hope you understand this line. So why extraction is not possible, we understood already, because of this issue. So now, if you come across any such question where there are both side groups like CH3 and CH3, answer would be no. Next important point is, what kind of groups we can consider for this attack. So NH2 minus can be written for the nucleophilic attack. It can be some CH minus COET kind of groups. Okay, so it is like malonyate kind of structures which can be used for this. So all these cases will end up giving you, let's say you start with this compound, so they will end up giving you, first they will come grab the hydrogen. Okay, let's say there is some X initially, so you'll grab hydrogen, remove it, X is out, and then later whatever groups you want, you can just bring it and get it connected. So it's like formation of this, and then Nu minus can come and join at a place. So you can expect Nu at this place or Nu at this place, and corresponding H will be joining at this place. I hope you understand this part, because Nu minus will come along with the H plus or the counterpart. So we have done this thing. Now let us see one example just for practice. Let's see this question. If we have OCH3, we have OCH3 here, and we have chlorine at this place, and the reaction is happening with NaNH2. Okay, NaNH2 in presence of ammonia. What is the answer for this case? So we'll say only this position is available for attack. This hydrogen is available for attack, Na plus NH2 minus. If you take this hydrogen, you're going to form this kind of structure. So it will become OCH3, and this is a bond here. So now what can attack? Ammonia can come and attack on this or this position, but major attacks we find that it will be at which place we'll decide. So let's do it both the ways. OCH3, if you say NH3 will attack at this place, where will minus charge form? So formation of minus charge at this place, NH3 plus at this place, and the second option is formation of NH3 plus at this place and minus charge at this place, right? So both the ways we can do this, and at the end, what's the final answer? You can go ahead with answer where OCH3 and H2 are little distant, because reason being is very clear. If you have a OCH3 group, you can say that this is a plus and minus I group, but in that case, if NH3 plus is sitting next to you, so if you try to support it later, H will not be easily given. So we'll say this kind of result, and finally we can talk about the products which are OCH3 and NH2. So these kind of products we can finally expect, and the next one is OCH3 and NH2. But to avoid steric repulsions and all, first one will be preferred, which is called amino anisole. So meta amino anisole could be one answer which we can think about. So like that we can see some more reactions here. But what about if the case is given, no doubt, if it is given that we don't have any nucleophile. So in absence of any nucleophile, very important. In absence of nucleophile, it is found that benzyne dimerizes and trimerizes. So it dimerizes and trimerizes, as the case may be. So we should know this example also. So what is this reaction all about? So we'll draw like this. You draw another member like this. Okay, and then it is 2 plus 2 cycloaddition kind of thing. So what will it give? It will give a ring here, connect it here, this part, something like this you can expect. So if you observe, left and right both sides are completely aromatized. So if you see the middle one also, there's a 4 bonds, that can be a problem, but otherwise this is the probable option. If there are 3 such rings, we can bring them like this. So let us suppose this is one, okay, then like that you can bring other members. So let's say this is other member, and let's say there's one more, something like this maybe. So what can happen if in this kind of scenario is given, you will again show the formation of compound which will be, so we can just take the whole thing and just correct it faster. So let's say we have drawn this. So now what I'm going to do is I'm just going to remove all these bonds. These bonds are going. In place of that, there is a direct connection now at what all places? It's like this. Please draw the structure. So these kind of compounds are possible when benzyne is not having any kind of nucleophile. Now benzyne can act as a diene and react with furane also or anthracene to form DAR product or Diels-Alder product also. That's the next reaction. So I hope this is clear. In absence of nucleophile, you can join it like this and you can form such products. Next is it acts as a diene and we can expect DAR reaction, which is called Diels-Alder reaction for this. So what will happen in this kind of reactions? We can first draw the structure of benzyne, which is like this. Draw the benzyne, and along with that you can draw the structure where you want to attack it. So as we say, like let's say you are attacking on anthracene ring. So in anthracene, when you draw anthracene, you draw it like this, okay, 3 rings, conjugated system, anthracene. And when it is phenanthracene, remember what happens in phenanthracene? In phenanthracene, you will draw the same thing. Just a second, you will draw the same thing and you'll keep it here, right? And what was naphthalene? Naphthalene was 2 rings like this. So this is naphthalene, this is phenanthracene, this is anthracene. So we are talking about right now anthracene. Let's keep it aside. Okay, anyway, so this we anyway know. Now come back to this. So if this is anthracene, you are attacking on anthracene, what kind of attack we can visualize and what kind of attack can happen in this case? So see, the left and right side are completely aromatic system. This one is completely aromatic system. This one is aromatic system. Even the whole structure is aromatic. But which ring will be more activated for such attack? So answer is the middle one. So what we can do is we can draw the structure like this, put a bond here, and then you show structure of anthracene in this way. It will be more useful if you show it this way. Look at this, how I'm showing like this. So I'm just putting, let's say there's a middle part, so I'm putting a double bond here and a double bond here, and let's say double bond here and double bond here, and then this side I'm just drawing remaining structures. So it's like you have double, double, double. Look at this structure now. So what happens? We can use this whole structure to draw the complete formation. So it's like you can say this is 2 plus 2 diene system. So if this attacks here, okay, this attacks here and this goes here. So normally we do in 4 plus 2 cycloaddition, this part. We do 4 plus 2 cycloaddition, so we can get this kind of answer. So if you just try to observe how will the whole thing look like, so I'll just take this thing and try to take all the bonds once again and show you how will it look like once you form the bonds. So see, this will go, and we can say this is shifted here. The double bond is coming to this place, observe. And what is happening? You have attacked at this place. So one connection is established from this point and the other connection established from this point, something like this. Okay, so you can do more better like this maybe, right? So this is the final answer that we can draw here. So observe, it's like this is a bicyclo compound. Now it is now a tricyclo kind of compound where all 3 positions we are having this kind of PH thing hanging over. So I hope you understood this reaction. In the next part, we will learn some more reactions of benzyne. Keep watching, keep liking and subscribing. Thank you very much.